Hi everyone, welcome to our webinar today, Bringing Characters to Life with Amazon Polly Text-to-Speech. Our presenters today are Robin Dautricourt and Felix Duchesneau. Robin is a Senior Product Manager with AWS, and Felix is a Software Development Manager as well. Before we kick off today's webinar, we have a couple of housekeeping reminders. Remember, this webinar is being recorded and we'll be able to send the follow-up links to the webinar deck as well as the webinar recording by end of day next week, Monday. If you're interested in finding that content earlier, you may search for it on YouTube or on SlideShare. While you're there, make sure to follow us on YouTube. Additionally, you'll notice throughout the entire presentation, there's a Q&A panel where you can submit questions for our presenter and moderators at any time. So engage with us and get your questions answered. At the end of today's presentation, we'll have some time for Q&A. So make sure to sit by and get your questions answered live.
Hi, my name is Robin Dautricourt. I'm the product manager for Amazon Polly Text-to-Speech service. And I'm joined here today by Felix Duchesneau, software development manager for Amazon Lumberyard, the AAA game engine. We're excited to be here today to talk about bringing characters to life with Amazon Polly Text-to-Speech. And in particular, we'll focus on Amazon Polly within the context of game development. Here's what we're going to cover in this webinar. First, I'll kick it off by talking about Amazon Polly. I'll give you a short overview of how text-to-speech is produced, and we'll cover some of the core features of Amazon Polly. We'll then talk about some of the use cases, and in particular, game development. And at that point, I'll hand it over to Felix, who will talk about Amazon Lumberyard, give you a short overview of how video games are made, talk about some of the cloud-assisted production tools, and share some of the new experiences that are made possible, in particular with the integration of Amazon Polly. Amazon Polly is a text-to-speech service that we launched at reInvent 2016. We currently offer 50 voices across 24 languages, and you can use this service to generate speech on the fly in real time. Once you've generated that speech, you can store it, cache it, and replay it locally, and reuse it as many times as you like. So let's take a moment to talk a little bit about text-to-speech and how that's produced, just at a high-level overview. So let's suppose that the text that you provide is what you see here. She has $20 in her pocket. One of the first steps that takes place is text normalization. So that dollar symbol needs to be converted into characters, TWENTY 20. So now that we've normalized that text, the next process is grapheme to phoneme conversion, or G2P. And so here what we're doing is we're essentially translating these characters into phonemes. The next step in the process is to associate each of these phonemes to a sequence of sounds. And through that, we generate the waveforms. Using deep learning techniques, we smooth out those waveforms to produce speech. Here's an example of what this would sound like.
She has $20 in her pocket.
Amazon Polly offers a variety of SSML features. SSML is an XML-based markup language which enables developers to annotate the text that they push to Amazon Polly in order to control the speech output. With SSML, developers control various aspects of speech. They can change the pitch, speech rate, add an additional pause, or otherwise control how the TTS system interprets the text. Let's go through a few examples. In this case, we've marked up this phrase using the volume and set that to extra loud. Here's what that sounds like.
I can speak normally, or I can speak in a louder voice.
In this case, we've set the prosody rate to be extra fast, so you'll note the change in speech rate.
When I get excited, I start to speak very fast.
In this example, we've changed the pitch to be high.
Sometimes when I get nervous, my pitch goes way up.
Another feature to touch on is speech marks. With speech marks, you can enhance the visual experience by combining audio and visual signals. In addition to the speech stream that you get from Amazon Polly, you can also request a second API. You can also make a second API request in order to retrieve metadata. This provides timing information for visemes, words, sentences, and SSML tags. Visemes are essentially the visual equivalent to phonemes. These are the facial movements that you make. And along with that metadata, you can create experiences that time that audio with the visual experience. A couple things you can do with speech marks are karaoke-style text highlighting or facial animation, lip syncing. Felix will give you some good demos of this later on. But we're here today to talk about Amazon Polly within the context of game development. In particular, you can use it within the pre-production phase of creating games. As you cast your characters, you can select which voices are going to be used for those characters, And you can essentially direct using some of these SSML tags to modify the way that these voices sound. In real time, you can generate new phrases, new things that these characters are saying, and you can store and replay that audio and use it over and over again as you're producing your game. And at this point, I'm happy to hand it off to Felix, who will talk to you about game development and Amazon Lumberyard.
Thank you, Robin. Once again, my name is Felix Duchesneau. I'm the Software Development Manager for Cloud Canvas on the Amazon Lumberyard AAA game engine. So what is Lumberyard? Amazon Lumberyard is a free AAA game engine that's deeply integrated with Twitch and AWS. It comes with full source code. There are no royalties, no seat licenses, or any subscriptions required. You only pay for the AWS services that you use, such as GameLift or Cloud Canvas. Today, we're going to focus on Cloud Canvas. But first, what's a game engine? A game engine is the software platform, the suite of tools, and the editor that developers use to build their game, to assemble the content that's going to end up into their game. So here we have a screen of the main viewport of the Lumberyard editor. We also have the component entity system that's opened right here that lets you add content to the level that's going to be the place where your game is going to take place. On the second screen here, we have Emotion FX, which is our brand new animation tool that was released in version 1.11. So when I talk about a software platform, I mean that beyond the assembly of the game content and all, you get all the services such as the rendering, the animation system, all the real-time features that let you deliver a real-time game to your customers. So here we have screenshots from our starter content, which is a sample that you can download to get all those cool assets, to see how the content is assembled into a product that is very similar to what a game would like as an end product. So first, let me tell you a bit about video game development. Video game development is very different than the creation of other media. Although the production cycle does follow a linear sequence, such as this one, you usually go through a conception phase, then pre-production, production, the game launches, and more recently, I would say, in the last 10 years, there is a big post-launch or live operation phase as games are more and more connected and have a way longer life once they are launched, with extra content being delivered as downloadable content, etc. When I said that the production of a video game is very different than other media, it's because all the pieces are moving at the same time. The environment into which the game will take place will be under construction for most of the production, for instance. We can't just select the location where we're going to shoot that sequence or go in front of a green screen and just act it and then put it together. The player, the NPCs, the non-playable characters, the gameplay mechanics, the storytelling, everything needs to be perfectly adapted to that environment, which once again will be under construction for the whole production. The assets, the characters, the character animations, the props, the audio will also be under development for most of the production, and everything will come together into a final assembly or in a final package very close to the end. So in terms of production timeline, although the conception, production, everything will be very sequential, we're looking at multiple teams working together all in parallel with several dependencies among them. So placeholders are going to be very important because we can't wait until the very end to put everything together. So placeholders will play a very important role, such as reserving physical space in the environment where the game will play, reserving memory budget, reserving time, timing-wise. Do I have time to say that sentence before that other thing happens? Iterate and play test. Finding the fun is going to go through multiple phases of adjustments and changes on the gameplay mechanics themselves. Test if there is enough variety. Am I always hearing or seeing the same thing? Localization is a very important part to having a game that's distributed worldwide. Those are many examples of placeholders. So let's look at one example. For instance, storytelling. A good game will have a consistent story in a consistent world, as opposed to a movie where the customers sit down and enjoys the experience that was tailored the same way for all the customers. In a video game, the player or the customer will evolve and will will go around into that environment and live the experience for himself. So the story will be told by the cinematics, which are more scripted, the scripted events, which are basically cinematics that takes place into the environment, the ambience and the dialogues and audio, the props and the accessories, the lighting, the change in weather conditions, all those things will be part of how we tell a story or how we deliver the story to the player. I've highlighted in blue the parts of that storytelling here that will be very tied to voices. But a game isn't a story, and that's an assumption that people that are not familiar with development often make. They think that the game is built sequentially just as the story is delivered. The hard part and what makes a good game is finding the fun, and the fun is found through playtest and iteration. So the fun will be tied to how well the player is able to understand what is going on, so how well we're able to communicate what is happening with the gameplay mechanics. But the gameplay mechanics are computer algorithms. So what we're saying is that the player must understand those computer algorithms. How? Through signs and feedbacks. There are many types of signs and feedbacks, such as UI elements, sounds, ambient dialogues, non-playable character dialogues, FX, and many more. Once again, highlighted in blue, those two are very tied to voices. Let's go through an example of a gameplay mechanic and see how it ties into the generation of synthesized voices. So let's take a look at the fictional example of a stealth game with a gameplay loop of 4 states. The first state, where the NPCs, the enemies, or the soldiers are relaxed, they are unaware of the player or have returned to their other duties such as patrolling, etc. An alert state, where the player has either been seen momentarily or has made some noise. A search state, where the enemies are aware of the player, they don't know where he is, but they are searching for him. And a combat state, they know where the player is, or at least they think they know where he is, and they are attempting to kill him. There will be transitions between all those states that we also want to communicate to the player so that he's aware of what's going on. So for example, the relaxed state, in the relaxed state, the enemies will be going from wait and play an idle animation to patrolling. And if ever the enemy is seen or heard, we will transition to the alert state. How do we communicate that transition? Did you hear something? What was that? What was that noise? NPC dialogues will play a very powerful part into communicating to the player that he hasn't been careful enough. And the thing is, with voices, the player could be looking somewhere else. He hasn't seen the NPCs, hence the fact that he's been seen. So those are audio cues that will be very powerful to let him know that, oh, he must be more careful. The alert state is nothing else than a detection meter. It increases as long as the player is seen or heard, and it decreases when the player is hidden. If the meter gets full, the player is detected, and we go to the search state. Once again, we want to communicate that transition to the player. Over there, I think I saw something. Show yourself. Who's there? During the whole search state, we're going to want to provide regular feedback that the search is going on. Come out, wherever you are. Hope you have a good life insurance, dude. It takes some guts to come here uninvited. Come out, we don't have all night. This will let the player know that he must be extra careful, because if he fails or if he gets seen again or heard again, then the conflict starts. Get him! There he is! Attack! Now that we've set the table for our demo, we can assume that our design looks great on paper, and we're going to use the text-to-speech cloud gem to implement it and play test it to get some feedback on how tight our gameplay mechanics are and how well they are understood by the player. So when you create a Lumberyard project, the first thing that you do is you open the project configurator and select the modules that you're going to need to build your game. Not all games are alike, so not all the modules would be necessary. The modules are cloud gems. Some of them include AWS resources. Those are called cloud gems. So for this demo, we're going to select the cloud gem text-to-speech. Now that our gems and cloud gems are selected and that our project has been rebuilt, we're going to access the Cloud Canvas Resource Manager to deploy the cloud resources to the AWS account of our choice, to our project's AWS account, so that our backend is ready to communicate with our game client. There are three parts to a cloud gem. First, the backend infrastructure that's going to be deployed in your AWS account. Second, the client component, which can be attached to any Lumberyard entity to provide access to the backend to that entity. And third, a Cloud Gem Portal plugin, which will be used to manage your backend resources. So in this demo, we're going to use the Cloud Gem plugin of the Cloud Gem text-to-speech to produce assets and audio files for pre-production purpose. So the first thing we're going to do is access the Cloud Gem portal through the Lumberyard editor. This will open a website that is hosted in an S3 bucket in your AWS account. All of the Cloud Gems that you selected have their own plugin in that web portal. In this case here, we see that we have the dynamic content Cloud Gem enabled, which has its own Cloud Gem plugin, and the text-to-speech plugin, which we're going to use for the rest of this demo. So what we're going to do is we're going to select the text-to-speech plugin and take a look at what we have in there. On the landing page here, we have a bunch of speech lines or dialogues that have already been created for the situations described in our gameplay loop. But the first step would be to go to the Characters tab and create the characters or select the voice profiles that would be the best match for the characters in our game. In this case, we already have one that's been set up here, an American soldier female that uses the US English language, which gives her access to the Joanna's voice profile. As you can see, we have the Vizime and sentence word options selected, which will enable animated lip sync and closed captioning. Now let's create a new character. Let's assume that our enemies are coming from multiple places in the world, so we're going to create the British soldier female. We're going to select the British English option, and my favorite voice is Amy. Once again, we're going to leave the Vizime and sentence word options selected so that this character can have lip sync and closed captioning enabled. And we're going to go to this little advanced setting option where we're going to have access to some of the SSML options that were described earlier by Robin. So just for the sake of this demonstration, let's say that the British soldier speaks very fast at a very high pitch. We can click the preview option right here.
Hi. My name is British Soldier Female.
So we're going to go back to the default options for rate and pitch and settle for a soft-spoken character.
Hi. My name is British Soldier Female.
That's perfect. So now that the characters for our game have been created, what we're going to do is we're going to go back to the speech library and start creating the dialogues that are going to match our gameplay loop. As a quick reminder, here are the states that we want to cover: a relaxed, alert, search, and combat state with transitions between them. So in the speech library, we already have some of those dialogue examples for all the transitions and states of the gameplay loop. We have one per state or transition. Let's take a quick look at this one here, which has SSML syntax in it. As you saw in the character tab, I was able to access the advanced settings option to set some SSML options on the character itself. Well, we also enable developers to use this SSML syntax in the dialogue themselves to override whatever has been set for the character. On the right here, we have our preview window, which lets us visualize what the lip sync will look like when playing those dialogues.
There he is. Must have been the wind. Over there? I think I saw something.
On the right of the preview button, we have the tagging system. So as you can see here, we can add any type of tags with a prefix that will let us filter the dialogues into different packages, such as the dialogues that are associated to any locations, the ones that are associated to a state, and this one, the trigger. Dialogues are not integrated into games one by one. Typically, the gameplay programmers, the game developers will go into the game and just invoke sound triggers, and then the audio engine itself will do the round robin between all the variations of the dialogues themselves, or make sure that they don't play too often, that we hear the most important at the proper frequency. So here, this one would be soldier transition from search to alert. So a programmer would just go in the code and call soldier transition to alert. Let's create a new speech line for our British soldier. So here we've selected the British soldier female voice persona. Let's duplicate that line, must have been the win. Let's add a new tag based on the weather. So weather win, there we go, we have a new tag.
Must have been the wind.
And that was a preview for our soft-spoken British soldier. So we have a very interesting tool to create new dialogue lines using the new speech line button, but we're very much aware that game developers, audio engineers, script writers are very attached to their existing pipeline, and that they will most likely use Excel spreadsheets. So we have the import CSV format option right there. So here we're going to go back to an Excel spreadsheet that has much more variety of the dialogues for all of the states. So I added like 4 per transition and per state. We can see our triggers here on the right that can be used to invoke those dialogues in game. Now that we've added a new character, let's duplicate all of these dialogues for our British soldier. Save that file, and we can go back to our CloudGem plugin and import the new speech line definitions. This window here lets me specify which columns are the character definition, the dialogue lines, and the different tags. All the prefixes will be matched to different columns. So here, let's import all of those dialogues. And that's it, we're done. All the new dialogues are available. As you can see, we now have 7 pages of dialogues.
What was that noise?
Let's look at the tag system once again. Let's select all the options that are factory specific. We've created some dialogues that are specific to when the enemies are looking for the player into a factory. This would be an example where we can preview this
Look
one.
carefully behind all those crates. They look like a good place to hide.
I can't see anything with all that steam.
Obviously, we don't want to say those dialogues when we're in the forests. We're going to filter them and package them in a different package. That would be an option to how we can use them or load them in game to save some memory, for instance. We can have a different package for the forest. But for the sake of this demo, let's create the generic package, which will be the biggest one. So we have 5 pages of dialogues here. We're going to select them all and create a speech file. This is going to generate all the dialogues using Poly, generate the zip, and allow us to download it to be used in our game. Obviously, this is going to take a little while because we don't generate the voices themselves unless you preview. or unless you generate the packages. That lets you iterate and change your mind plenty of time before invoking the poly service. So this is going through all of my dialogues and invoking the poly service to generate the audio files and the speech marks. You can see on the right here with the little cloud that says 1 that there is a speech file creation in progress. And that's it, our package is ready to be downloaded. So I'm going to create a new generic gameplay dialogue package. Okay, so now that our package has been generated and downloaded, we're going to look at what it contains. All of the dialogue lines have their own PCM files here, and a text file that is the speech mark file. If we look into the speech mark file, we can see that it has timing instructions and sentence, word, and visime values for all of the keyframes, if you want, or the key time values in there. So what we're going to do now is we're going to install the sound package or the voice package into our game. We have a command line tool to do that. LMBR AWS Cloud Gem TTS import TTS zip -- download path, your download path. The engine can use the package as is, but most of the developers, or a lot of them, are going to want to integrate those dialogues into their audio solutions such as WWise. So we have the option to specify -- import as wave, which will convert all the PCM files to wave files, which is a preferred format for most audio engines. For the sake of this demo, we won't go through the Wise integration and make this package available as is to our game. So we're going to go to the Lumberyard editor now that the package has been extracted and installed. And we're going to look at this simple sample. All the cloud gems come with a sample. So this is a very simple example of how you can integrate the text-to-speech tech to your game. So we're going to select the talker entity and look at the components. It has a speech component, a text-to-speech component, and a cloud gem text-to-speech client component. The text-to-speech client component lets the game access the feature at runtime, which we won't do right now because we want to showcase the package extraction. So we're going to specify an optional character profile, which is going to be the British soldier female. For the sake of the demo, we're going to select a voice, which is also optional. So we're going to select Justin, which is a kid's voice, and then we're going to type one of the dialogue lines for our signs and feedback.
Must have been the wind.
As you can see, the voice was found immediately and the Justin option was ignored because we found a matched and installed dialogue line that matched the British soldier female in our package. If we try that same line with the Justin voice again, remember that the text-to-speech client component is activated on this entity. So we're going to type the same sign and feedback.
Must have been the wind.
And you're going to notice that there was a delay here because we didn't find that dialogue line for Justin, which doesn't have a character profile. So now this voice has been generated at runtime.
Must have been the wind.
And it's been cached, and next time that it's invoked, it's available. So in this demo, we presented the pre-production use case, but this is just one example. As mentioned, the Cloud Gem also enables runtime text-to-speech generation. For example, there is a big buzz around systemic experiences and procedural storytelling, but natural language has always been the barrier. Text-to-speech is a big step, not to say a leap, in the direction that would let the player build his own experience in the world that we've created for him. From here, we leave it up to your imagination to use that tech to create new gameplay experiences. That being said, I'm going to leave you on one last video of the runtime capabilities of the text-to-speech Cloud Gem.
The Cloud Canvas text-to-speech Cloud Gem uses Amazon Polly, which is a text-to-speech service that turns text into lifelike speech. Amazon Polly offers dozens of lifelike voices in a variety of languages. The service also creates lip synchronization and closed captioning from the text that you provide.
Thank you, Amy. That was a good recap of what I just said. Thank you, everyone. It was a pleasure to be here and to show you that technology. I hope that you are fascinated and captivated by what it offers. My name is Felix Duchesneau. Again, it was my pleasure.
Thanks, Robin. Thanks, Felix, for a great presentation. That was an awesome demo from start to finish. Thanks so much, everyone. Before we transition into the live Q&A, please take a couple of seconds to answer the polls that you see on your screen here. And additionally, we'll be back in just a couple of moments after our presenters grab a drink of water. Again, if you have any feedback for us, please make sure to send us an email at aws-webcasts@amazon.com. Thanks, and Robin and Felix, back to you.